Hi guys, in this video I'm going to show you a simulation of an AC generator, how the electricity is generated. As we know that ESCOM uses the AC generator. So here, if you can see, the coil is being rotated using the windmill. So the windmill is doing the mechanical part on the coil, which is rotating the coil. So while the coil is rotated, there's an EMF that is induced there, right? If you look at the bulb lit because of there's an EMF that is induced. If you look at the external circuit, there are arrows there. But if you look at those arrows there, they changes the direction. That means they changes the direction every half a cycle, those red arrows. Do you see the bulb is on and off? Because when the coil is vertical, there's no EMF is induced. When the coil is horizontal, there's an EMF that is induced. Now let's try to rotate the coil faster. Let's change the speed of the windmill, which is the mechanical part. If you look there, do you see the bulb? Lit so quick there. Do you see? I have increased the speed of the speed of the rotation. That means there's more EMF that is what is induced there. Let's introduce the magnetic field. Do you see the magnetic field lines there? There are magnetic field lines there, which is they creates the magnetic flux, which is the magnetic flux as the magnetic flux linkage there. Now let's change the bulb now and see if you have the galvanometer. So if you look at this, okay, let's do it slower. Let's do it a little bit slower. Look at the coil when it's vertical. You see, when the coil is vertical, the EMF that is induced is zero, and then when the coil it starts to be flat, but it doesn't show easily. When this coil is flat, there's an EMF that is induced there. Now let's look at the graph of an AC in oscilloscope. The oscilloscope, it shows the graphs. Do you see there? That's our rotation. That will be our graph. But look at when I increase the rotation. That means there will be more voltage and there will be more frequency on the look at that. Look at that, the change in that. Do you see? There's more frequency. There's more frequency. That means when I mean more frequency, that means more rotation per second. So the coil it rotates faster. That means there's more rotation. There will be more frequency. There will be more current. There will be more induced EMF there. Right? And if you look at the magnetic field lines, they're going from what? From north to south there. Right? And look, when I increase more the speed, there will be more what? Do you see the peak? That means there's more current, more induced EMF, more frequency there. What do you mean about more frequency again? That means more rotation per second, more complete waves passes a point, right? And let's look at the bulb. If you see the bulb is more brighter, that means there's more current there. Guys, I hope that makes sense.